So here we're going to review strategy on verifying trigonometric identities. Basically, the methods, the work that we have done for 5.1 and 5.2. Mainly for 5.2. So the first thing it states is start with the more complicated side of the identity and work to transform it into the simpler side, keeping the other side of the identity in mind as your goal. Second one, use reciprocal, quotient, Pythagorean, and other basic trigonometric identities. So to review, make sure you know these identities just like how we've been using it in class and the identities that I have used in my video. Third, use algebraic operations such as combined fractions, rewriting fractions as sums or differences, multiplying expressions, or factoring expressions. So this mainly ties into, we already know about combined fractions and rewriting fractions, such as rewriting in sine and cosine, but it's also talking about when we are multiplying by the conjugate and we are foiling. So like factoring expressions or multiplying expressions. The next part, convert a denominator of the form 1 plus a negative plus or minus u, or u plus or negative or plus and minus 1 to a single term using its conjugate and a Pythagorean identity. So this ties into verifying trig identity by multiplying. So you multiply by the conjugate to get a Pythagorean identity. And you have seen how having a Pythagorean identity change or switch out or replace a complicated term into a simpler term. Next, work each side separately to reach a common intermediate expression. We haven't gone over that. We may or may not go over that. But there are going to be some example where both sides you may have to work on to get it into a simpler term or a simpler expression. Lastly, if no other strategy presents itself, try converting the entire expression to one involving only sines and cosine. So, like I said before in the videos and like I said in class, if you feel like you're stuck, if you feel like you don't know what else to go on, to do on your examples, on your problems, such as like a problem on a test, you can always convert it into sines and cosines, and it'll help you a lot based on my experience. Now, after you convert it to sines and cosines, you still have to remember, use algebraic operations such as combined fractions, rewriting fractions, multiplying expressions, or factoring expressions. So, after you convert to sines and cosines, you still have to do what we had done since the beginning of the school year, adding, subtracting, using algebraic operations, especially if you're doing multiplying and dividing fractions. So again, if you're stuck, don't know what else to do, convert to sine and cosine, and keep working.